Darren, are you ready?
I think I'm ready. Let me share my screen.
Awesome. Do you want to briefly introduce yourself? I'm not sure. I guess everybody knows you, but just in case.
Sure, I can introduce myself. First of all, I want to make sure you guys can see my screen. Does everybody see my slides?
Yes, we can.
Excellent. Okay, my name is Darren Nattinger. I am a longtime NI employee. I've worked for NI for over 22 years. And most of that time I spent in Labview R&D working on a lot of the features you saw in Stefan's presentation and a lot of the stuff I'm about to show you. About a year ago, I moved over into the tech support department at NI, which is where I'm at currently. So there's going to be a bit of overlap in the content that I'm about to show. I'm going to go into every possible detail of the right-click plugins feature that Stefan covered toward the end of his presentation. So I'll go ahead and get started. All of the content you're about to see is on ni.com/lvmenus. If you go to that page, that's the enthusiast page for the right-click plugins feature of Labview. There's a link at the top of the page that says comprehensive introductory presentation. That is the presentation you're currently seeing. You can download the slides and all the demo files from this presentation at ni.com/lvmenus. By the way, I don't see I guess just through the way my screens are arranged right now, I'm not looking at the chat right now. So if you guys have questions during the presentation, feel free to unmute and ask me, or I can get to them at the end when I can move screens back around. All right, so the first thing I'm going to talk about is how there are a lot of different ways to augment the Labview editor. But then I'm going to get right into the bulk of the presentation, which is the right-click menu plugin feature. I am going to demo building a basic plugin. I am probably going to quickly demo the inventory of shipping plugins since Stefan already covered a bunch of those. Then I'm going to talk about some of the tools that are available for developing your own. And throughout the course of my demos, you may be wondering why we designed the feature the way that we did. So I've got a few topics related to the decisions behind the design of the plugin feature. And then a few caveats and pro tips to keep in mind while you're working on your own right-click plugins. So right-click plugins are just one of the many hooks that there are in the Labview editor. You saw Stefan demonstrate several of them, like the quick drop plugins and the right-click plugins. I have given a presentation on every single possible way that you can hook into the Labview editor with G-code. And that presentation is at bit.ly/dnatlvhooks. And in that presentation, I talk about all the topics that you see there on the slide there: quick drop plugins, right-click plugins, analyzer tests, all the different ways you can plug into the editor. So even though I'm just covering one of those ways right now, know that there are many, many different ways that you can write Labview code to plug into the Labview IDE. So, but we are here today to talk in gritty detail about right-click plugins. This feature was added in Labview 2015, so we've had it for a while. But prior to Labview 2015, if you wanted a new right-click menu item in the Labview editor somewhere, you would have to go ask a C++ developer in Labview R&D really nicely if they would add the feature for you. It was not possible for Labview programmers like ourselves to add right-click menu items into the editor itself, but this was added in Labview 2015. There are two different types of right-click plugins. The one that I'm going to talk about pretty much exclusively in this presentation are edit time plugins. So there is no VI running. You are editing VIs in Labview, and you right-click on things, and there are items in those right-click menus. That is the type of right-click plugin I'm talking about. It's also possible to write runtime diagram plugins. So while the VI is running, you can write G-based right-click menu items for the right-click menus on the block diagram. Those are much more rare. You very rarely see those. They tend to have to do with things like optimizing things with breakpoints and probes, really, is about the only things you can do there. Now, this feature does not apply to menus whenever you right-click on a front panel while the VI is running. And the reason for that is we already have had that feature for many, many years. That's RTM files. So you can define custom runtime menus for while your VI is running. Now, there have been a few use cases identified where it would be nice to be able to write right-click plugins that also worked on front panels at runtime, but that is not part of the feature currently. So for all intents and purposes, we're talking about editor features for the Labview editor to make us more efficient. There are ways that we can write plugins for that. Now, you may notice that I'm using the word augmenting instead of adding. And that's because right-click plugins allow you to do more than just add right-click menu items. They allow you to add hierarchy in the menu, so you can add pull rights if you want to. Right-click plugins actually allow you to remove menu items. I wrote a right-click plugin one time to remove the convert to stacked sequence structure menu item on a flat sequence, just because I thought that was funny. You can also replace existing menu items. There's a few right-click plugins that ship with Labview right now that replace built-in menu items to do something more custom. And then another way to augment the menus, you can disable menu items or put checkboxes next to them. You can do all of those things with this feature. That's why we talk about augmenting the menus, because it's a lot more than just adding new things. So there are 4 steps to building a right-click plugin. The first step is to create the plugin, and plugins are LLBs, and I'm going to talk about more about why that is later. Then you update the affected items type def, you update the builder VI, and you update the execute VI. Those are the 4 steps for building a right-click plugin, and I'm going to go through those 4 steps right now in a demo. So I'm going to bring up Labview, and I'm going to open up a tool that ships with Labview that lets you create new plugins. And resource plugins pop-up menus, there's a VI called Create Shortcut Menu Plugin from Template. And I'm going to create a plugin for doing spell checking. So that's my demo today, is a plugin that'll create a spell checker. So I'm going to call this plugin spell check, and I'm going to run the VI. And this is going to create the plugin for me and open up the VIs for me to be able to edit. All right, now remember I said step 1 is to create the plugin LLB. That's what I just did by running that tool. Step 2 is to update what's called the affected items type def. This defines which objects in the VI that you right-click that this plugin will operate on. For our purposes, we are writing a plugin that is going to do a spell check on string controls on the front panel. Now, we could say that this thing will spell check anything. Like if you right-click on a while loop, we'll spell check its label. Or if you right-click on a wire, it'll spell check the wire label. We're not going to do that today. We're just going to define a plugin that does a spell check on a string. So what I have to do is I have to tell the plugin, I only want you to operate on strings. And so to do that, I go into the affected items and I change its class to string. I could add other items here too. If I wanted this spell checker to work on string constants, for example, I could add another array into this affected items cluster of string constant references. In this case, we're just going to operate on strings. So I'm done updating the affected items type def. So that's step 2 of writing my plugin. Step 3 is to write the builder VI. This is the VI that runs when you right-click on a string. And there's a bunch of comments in here. Don't worry about reading all those right now. That's all part of the template. But this is the VI that allows you to figure out whether or not you want to provide your right-click menu, how you want it to appear in the menu system, like where you want it to appear, whether or not you want to add additional menu items. You have access to the VI that contains the item that was right-clicked. You have access to the menu that is about to be displayed for that control. So a lot of things in here that you can do for when the user actually right-clicks. What do you want to do? How do you want to construct the menu item? Well, in our case, I'm just going to leave this VI alone. By default, this is going to insert our menu item at the very bottom of the list. That's fine with me right now. If this were something I was wanting to be more fancy, I'd probably do a little more customization here. But in our case, we're just going to leave the builder VI alone because all it's going to do is put the menu item at the bottom of the list. So that's perfect. I don't even have to make any changes here. The 4th and final step for building a right-click plugin is to write the execute VI. This is the VI that actually does the scripting to perform whatever editor operation you're wanting to do. So I'm going to delete these comments here just to get some room on my diagram. So I have an array of all of the strings that were right-clicked here. So what I want to do is I want to do a spell check on those guys. Now, at this point in the demo, I'm going to cheat a little bit because I already have a sub-VI written that does a spell check for a string control. So it would have taken me a little too long to write all this code as part of the demo. So we're just going to, that's my cheating. I already have it written. So what I'm going to do is I'm going to do the spell check on the control. And if there were any spelling errors in any of the strings that I spell checked, then I am not going to fail the transaction. Failing the transaction means you tell Labview, pretend like the right click never happened. And you would want to do that in cases where maybe there was an error, or in our case, if all of the strings that we're spell checking don't have any spelling errors, then there's nothing to do. So we can fail the transaction then. So that's that logic there. So I cheated a little bit with my sub-VI, but I'm done writing my right-click plugin. We are now ready to try this thing out, except for one other step, which is we need to refresh the menu system in Labview and tell Labview, hey, there's some new plugins that you need to load into your system. So to do that, I'm going to use the refresh menus VI. Now, this is a VI that I already have available in QuickDrop and the palettes because I have the Hidden Gems package installed. If you've never seen my Hidden Gems presentation, it's about all the really cool, useful things that ship with Labview, but they're not in the palettes and they're not in QuickDrop by default. That presentation is at ni.com/hidden gems. So if you want to go check that out, that's where you can get things like this cool palette of VIs that have all the hidden gems that are part of Labview. But anyway, refresh menus is a hidden gem. I'm going to run it. And our menu system has now been refreshed. So now let's try out our spell check plugin. I'm going to open up a VI that has a bunch of string controls on its front panel. And these string controls have a bunch of misspellings in them. And so what I'm going to do is I'm going to right click on a string and check it out. There's our new menu item. That is the plugin that I just wrote. You see it is now in the menu system because I refreshed the menus. And if I do spell check, you'll see that all misspelled words in that string are turned red. That's what the spell check plugin does. It also works for multi-select. So if I highlight multiple strings, we see that the menu item is still in the list, and I do spell check. It's going to highlight in red all the misspellings. We use the built-in transaction mechanism of right-click plugins to handle undos and redos. So if I'm in this VI and I just do undo, I'm pressing Control-V right now, it'll undo those things. So as you can see, right-click plugins, and not only are they relatively easy to write, you saw that I went through those 4 steps pretty quickly, but they also integrate into the Labview editor, just like all of the built-in right-click menu items. If I right-click on a string, there's a lot of things in this list that are based on C++ code that is part of the Labview IDE, but there's also lots of things in here that are based on right-click plugins, like this spell check that I just wrote. Change to array, which I'm going to demo later, is another example of a right-click plugin. So you can see that these features, these right-click plugins, integrate into the menus just like built-in Labview C++-based features do. So that's my first demo, how you can write a right-click plugin from start to finish in the 4 steps that are required. I'm going to go back over to my slides here. And I'm going to talk about how there are a lot of these plugins, as I mentioned, that ship with Labview. Now, the feature came out in Labview 2015. And in Labview 2015, Labview Core shipped with 8 right-click plugins. Labview 2021 shipped with 31 right-click plugins. So you can see Labview R&D has really embraced this plugin feature, and it allows Labview R&D to add features to the editor much more rapidly than they otherwise could with other mechanisms like the C++ based features. So I'm not going to call all of these out individually on this slide. Just know that a lot of these plugins, I wrote a lot of these, a lot of other Labview programmers that and I wrote a lot of these. But as Labview version releases have progressed, we've been able to add more and more of these right-click based plugins into the editor. Now I'm going to go back into Labview and open up a VI. Now you're going to see that this VI that I'm going to open up is very similar to what Stefan showed with his plugins. However, Stefan's demos included a lot of plugins that are on ni.com/LV menus. They're community-based plugins. Every single plugin I'm showing in this demo right now ships with Labview as of Labview 2020. So you don't have to download anything to use any of the plugins that I'm showing in this demo right now. And the first one is Empty Listbox. And I like to show this one first because when I first learned Labview back in January of 1999, we were, learning the basics of the language. We're learning about data flow and wires and loops and, all that stuff. Well, on the front panel, they were showing us, Booleans and strings and numerics, and they showed us list boxes. And so I was playing with a list box, brand new to Labview. In my Labview training, I added a bunch of stuff to the list box, and there was no way to get rid of the stuff in the list box. I actually had to write code to wire an empty array to the items list of the list box. Either that, or I had to go in and right-click and do delete row like a jillion times if I had a list box with a bunch of things. So over 22 years ago, I said, hey, there should be a way to delete everything in a list box. And I had to wait, 16 years until I had right-click plugins, at which point I was able to implement the feature myself in like 10 minutes. So, which I did. This was the first plugin I wrote, which was Empty List Box. So now you can right-click on a list box and do delete all rows. So that feature is a right-click plugin. Then we have change to array element. This is one of my favorites. I use this a whole lot. You can right-click on a scalar item on the front panel and do change to array. And of course, you can do the same with a multi-select. And similarly, you can right-click on an array and do change to element, and it'll turn it into the scalar of that item. I love this plugin. I've been using it since day one. Another right-click plugin is Transposed to the array. So this is an example of a right-click plugin that we inserted into an existing pull right menu. So if you right-click on anything on the front panel, you're always going to see that data operations pull right. Well, Transpose Array, that's a right-click plugin. And see, it's sitting right next to a C++-based feature, which is Empty Array. Empty Array is not a right-click plugin. These right-click plugins can integrate into the menus as seamlessly as all of the built-in stuff, and we can transpose the array there. Stefan showed this one. Well, I think he showed it on the block diagram. You can right-click on an enum and do select item, and then you get this quick drop-like UI where you can type in something and very quickly find that item, which is really useful when you've got an enum with pages and pages and pages and pages and pages of things. It's a lot harder to navigate. And then a really simple right-click plugin, you can right-click a variant. And again, in the data operations menu, we have this right-click item to clear data, to empty the variant. Those are all features that are implemented as right-click plugins on the front panel. On the block diagram, we've got things like Explore sub-VI. So you can right-click on a sub-VI and do Explore, and it'll bring up a Windows Explorer window that navigates to the folder on disk to where that VI lives. It opened up on my other screen here, so there you go. It highlighted the VI. If you do this on a VI that's inside of an LLB, like this one is, and do Explore, it'll open up Windows Explorer and highlight the LLB. So we have some features in Labview that are implemented not only as quick drop plugins, but also as right-click plugins. So Stefan showed you that you could highlight these controls or these objects right here and do Control Space Control R, which will do a removal. I'm going to undo that, and I'm going to do the same operation with a right-click remove and rewire. It does the same thing. And similarly with other nodes, we can do the same thing and do the right-click and rewire, and pass-through wires are kept. We tried to find features that were very popular as quick drop that might also make sense to operate on individual objects with right clicks, and we added those as right click plugins as well, because the quick drop plugin feature has been around since 2009, and the right click plugins feature has been around since 2015. So we had several years of development of quick drop plugins before we were able to do right click plugins. So some of that stuff got moved over where it made sense. Size to widest element. So this looks like an array that has 1, 4, 5, 2, 8. But if we do size to widest element, we see that a lot of those guys were actually hidden. And this works on enum arrays and string arrays as well. This is another one that's a quick drop plugin. If you select an object and do Control Space Control D, you get all the controls. If you do Control Space, Control Shift D, like Stefan showed, you get all the constants. Here's this isn't a quick drop presentation, but I'm going to demo a quick drop feature anyway. If you press Control Space and type in REQ before you create controls or indicators, it's only going to create the required ones. So nifty little trick there. But you can also right click. So right click and do create. You now have all controls and indicators are all constant options. And of course that works for multi-select too. And keep in mind, all of these items that I'm talking about are built-in right-click plugins. You do not have to download anything to use any of these. I believe Stefan showed this one. This is Rearrange Cases. Rearrange Cases used to be a really crummy looking UI. And as you can see, it's now a nice resizable UI, which allows you to do things like delete cases. This was implemented as a right-click plugin. So everything you're seeing here is G-code. And this is an example of a right-click plugin that replaces an existing built-in menu item. So we're not adding a new thing with this right-click plugin. We are replacing Rearrange Cases with a right-click plugin instead of the C++-based Rearrange Cases feature from earlier Labview versions. This was a feature that Jeff Kodosky, the father of Labview, asked me to add, which is you can highlight comparison functions and replace comparison as a menu item, where you can replace one or more comparison functions with different ones. And I think Jeff asked me to add that because he saw this feature that I added, which was replace conversion. So you can right click on conversion bullets and see a list of all the other conversion bullets to be able to replace them with. But I'm getting ahead of myself. So this is the one that Stefan showed. It's very similar to the one of the enum on the front panel. Showcase now lets you type in and be able to, in a quick drop-like way, navigate to a case, which is way better than having to navigate. In case you didn't know, you can use page up and page down in these menus. So you don't have to hover over the arrow for forever with a really big list. Page up and page down helps you navigate more quickly. That's what I'm pressing on my keyboard right now. But even faster is the ability to just do showcase if you already know what the name of the case is that you're looking for. Create cluster from selection. This also works on the front panel. And Stefan showed change mechanical action from the block diagram. Prior to this being added as a right-click plugin, you could only change mechanical action from the front panel. I showed the replace conversion. This is one of my favorites. Whenever I'm working with colors on the Labview block diagram, or even on the front panel, I always want to be working with a color box. And it annoys me when prior to what I'm about to show you, if I was working with, say, like the color property on a property node, and if I did create constant, I would always get a numeric constant that looks like what you see on my block diagram. Well, there is a right-click plugin that you can do to replace a U32 with a color box constant. And that will replace it like that. And if you want to go back, replace with U32, we will put it in hex and show the radix, in which, in my opinion, it's a lot easier to discern this as a color value than to discern this as a color value. Along those same lines, I believe it was in Labview 2019 where we added this feature. If you have a property that would create color data, like this colors property on the Boolean class, if I do create constant, check it out. I get a constant with color boxes in it. I love that. Anytime you've got a color parameter on a VI or on a property node, if you do create constant or create control, you will get a constant or control that has color boxes in it instead of just regular U32 numerics. I really love that feature because it makes it a lot easier to work with colors on the block diagram. All right, so next is create events. I love this feature. If you right click on a control or a terminal and do create event case, that is so much easier in my opinion than going and having to add event case and then having to work through this dialog. I mean, this dialog isn't terrible, but a single right click menu option is way better than having to navigate that in my opinion. All right, Stefan showed this one. Normally when you do create constant on an array terminal, you get an array data type, which kind of makes sense. Well, we've got the pull right that lets you create a scalar constant or control. And again, these are all built into Labview. Now, some of the ones I'm demonstrating originated on the right-click plugins enthusiast group on ni.com. This is an example. Create Scalar Constant was originally a plugin you would have to download, but a lot of the more popular plugins we pulled in as official features of Labview in later releases, and this is an example of one of those. The one I showed before, or I'm sorry, that Stefan showed before, create sub VI from wires. One of my favorites. I wrote this plugin. I'm proud of it. I use it quite a bit. It's really useful when you know you need a sub VI that operates on some data types, but you don't want to create like the dummy structure or the dummy nodes or whatever that you would have to have in order to select, edit, create sub VI, which requires at least one non-wire object be in your selection before you can use it. Stefan showed this one, insert in place element structure. Pretty handy for working with clusters and classes. This is one that was added, I believe, in Labview 2020 or Labview 2019, where you can set the justification of text in string and path constants. This one I like just because it's fun to demo. This code pattern is pretty common in unit tests, where you've got a lot of things that you're checking, a lot of conditions you're checking to see if the unit test passes. And if the unit test fails, it's sometimes a pain to figure out which one of these, 15 or 20 conditions is what caused the test to fail. So there's a right-click plugin, and now this is one of those rare examples where this is a plugin that can also be used as a runtime diagram plugin. So all of the ones I've shown up to this point are edit time panel and diagram plugins. This one is a runtime, or it could be a runtime diagram plugin where while your VI is running, you could actually do this, where you right click and do probe all inputs, and it creates a probe on all those inputs. Now, whenever my unit test runs, I can very quickly look through the list and see which one of these was the false that caused it to fail. And that's it. That's all. I mean, that is not all of the shipping plugins. Those are all the ones that I thought it would be easy to demo. You saw even more of them, I think, in Stefan's presentation. But remember, every one of the plugins I just showed ships with Labview. No extra downloads required to use any of those. All right, so what tools are available for developing right-click plugins? The best tool is the Labview documentation. So there's a topic in the Labview documentation called Understanding Shortcut Menu Plugins, and that's where you want to start. That documentation goes from start to finish on how to write a right-click menu plugin. Another tool is the plugin creator. Y'all saw me run that at the beginning of my first demo. That is always how you want to create your plugin. You always want to create it with the plugin creator. And then there's the refresh menus VI that I talked about before. By the way, all of these utility VIs are in resource plugins pop-up menus. So there's the creator that I talked about before that I used in my demo. And then in the support folder are several useful VIs. For example, the refresh menus VI that I used, that's in the hidden gems palette, that's in here. So plugins pop-up menu support, that's where you want to go to find these utility VIs that I'm going to be talking about in the rest of the presentation. And one of the best tools for developing plugins is to look at the diagrams of existing plugins. So remember I talked about how there's like 31 plugins that ship with Labview? Well, those are all right here. And almost all of these are not password protected. So you could go in and start digging through the code of these plugins and learning how they work. So the utility VIs. One of the most useful utility VIs, and I didn't include this in my demo, but it's definitely something you want to look at, is the look up all shortcut menu tags and types. Now that itself is a right-click menu plugin. So in order to use it, what you do is you copy that LLB into the folder where the plugins live. And once you've done that, every time you right-click on anything in the Labview editor, you will see a menu item in that menu called Look Up All Shortcut Menu Tags and Types. And when you pick that, a window pops up and basically tells you a bunch of information about what you right-clicked on. It tells you what the class of that object is, like the VX server class. It tells you any additional items that were included in that right-click. For example, if you were on a block diagram, and there was a loop, and you right-clicked on a terminal of that loop, you will learn as you write your right-click plugins that the plugin menu system is going to activate for the terminal class, the tunnel class, and the loop class, because all three of those things are included in that area that you just right-clicked on. And your plugin has to figure out, do I care that this is a loop tunnel? Do I care that this is an outer terminal? Remember Stefan's demo where he created the constants on all the unwired constants inside the case structure frame? That plugin was probably checking to make sure you were right-clicking on an inner terminal of a structure instead of an outer terminal. That's the kind of thing that these tools can give you information on. And that's the kind of thing you'll see these tools being used in the existing shortcut menu plugin diagrams if you start navigating through those to learn more about how they work. So the community group, I already gave this link before, ni.com/lvmenus. This presentation and these demos are there. And there's a lot of additional resources for developing plugins. One of the best things about this group is that you can post questions that you have. Like if you're writing a plugin and you run into a problem, you can ask on the LV Menus community group and people will help you. And of course, probably one of the best resources is the fact that this is where you can download dozens of additional plugins. At my last count, there were over 80 available. Stefan demonstrated several of them during his presentation. Lots of great ways to augment the Labview editor with those community-based plugins. And like I said, some of the more popular ones end up getting pulled into the Labview editor for everybody to use just because of how useful they are. All right, so let me talk a minute about why we did some things the way that we did. So this feature, like I said, it was added in Labview 2015. There were two primary developers for this feature. My colleague, Stephen Loftus-Mercer, who a lot of you know, he worked on the C++ side of this feature, basically building the plugin framework. And I worked on the G side of this feature, basically, providing feedback to him about the kinds of things that I needed my right-click plugins to be able to do that the framework needed to support. So one of the things that we decided pretty early on is that right-click plugins would be packaged as LLBs. Now, LLBs get some bad press. People don't like LLBs. They don't like that they aren't really that compatible with source code control, because now you've got one file, but it's got several VIs inside that file, and it makes sort of version tracking harder in source control, which is a totally legitimate issue. Another concern is that LLBs can sometimes get corrupted. That doesn't really happen anymore. It used to happen years and years ago. I'm sure it does happen, but it's a lot more rare now. But despite those downsides, there are some pretty cool things about LLBs. For one thing, like I said, it's a single file. If you go to ni.com/lvmenus to download plugins, you can download an LLB and drop it in a folder, and you've got your plugin now. It's very portable. Well, one of the best things about LLBs that a lot of people don't know is how fast they are. If you have a group of VIs on disk that you need to load into memory, the fastest way to do that is with a PPL, a Pack Project Library. That is the fastest way to load a group of VIs into memory at once. The second fastest way is an LLB. So we wanted our plugins to be version independent. For example, if I write a plugin, a right-click plugin in Labview 2015, and I give it to you and you put it in your Labview data folder, which is one of the places plugins can go, then on your computer, any Labview version from 2015 and later will be able to use that right-click plugin. If we had made this a PPL-based feature, that would have been harder to do. Now, granted, this was back in 2015. We didn't know that in 2017 PPLs were going to get the forward-looking, version compatibility feature that they have now. But at the time, LLBs seemed like they were the fastest way to load code and still be version independent. So that's why we used LLBs for right-click plugins. Now, remember when I built the plugin in my first demo, the first thing I did after I created the plugin LLB was I went to the affected items input and I changed it from I think it's gObject by default. I changed it to string so that my plugin would only work on strings. Now, one of the reasons why we do that is because we want this feature to be fast. We want right-click plugins to be as fast as possible, because when you right-click on something in the Labview editor, there is nothing more annoying than having to sit there and wait for something to happen. I hate when that happens in the project window. I hate when it happens in the Labview editor. We need right-click menus to be fast, and this is a G-based feature, so we're loading VIs and running VIs. We want things to happen as fast as possible. So what this allows us to do is when Labview first launches, and when you run the refresh menus VI that I showed in my demo, Labview does a computation of which plugins apply to which types of objects. That is all determined ahead of time. So if you right-click on a while loop, Labview is never even going to think about my spell check plugin that I wrote, because it computed at runtime, at launch time, or when I ran the refresh menus VI, that plugin only applies to strings. So when you right-click on a while loop, it's not even in its field of vision. It's going to only do things that pertain to while loops. And the way we can accomplish that is with the affected items input. So that is why we took that approach, to make you have to define what types of objects your right-click plugin can affect.
Darren, a quick question.
Yes,
came up from Tom McQuillan. Do LLVs load individual VIs into memory, or do they load everything inside the LLV into memory?
That's a great question. So the question is, when you have an LLV, does everything in the LLV get loaded into memory? And the answer is no. If you have an LLV full of 10 VIs and one of those VIs in there you want to load into memory, and it has no dependency on any of the other VIs, no, those other VIs are not going to be pulled into memory. But if you have a set of VIs that all depend on each other, and you know that if one of them is in memory, all of them are going to be in memory, that's when it makes sense to use an LLV, because all of those VIs need to be loaded. If those were individual files on disk, let's say so that right-click plugin that I wrote, the spell check one, that's got 3 VIs, the affected items type def, the builder VI, and execute VI. All 3 of those VIs always have to be around when you're using that right-click plugin. No, there's no exception. So if those were 3 separate files on disk, Labview would have to do 3 file operations to load those 3 VIs into memory. When those 3 VIs are inside of an LLV, there is 1 file operation. Labview gains access to that LLV file, and then it starts to load the VIs into memory, and that's why it's a lot faster. So, okay. So that's why I said. Notice in my slide, I say it's fast to load a hierarchy of VIs. So if you've got a group of VIs, you know they all need to be in memory. The LLV is going to be the second fastest way to load those into memory because of the low number of file operations on disk that Labview has to do. So hopefully that clarifies the question.
I think so. Thank you.
Great. All right. So last thing on this slide is the 2 plugin folders. So as I mentioned at the beginning, at the introduction, I worked in Labview R&D for 18 years. I had my hands in a lot of features of Labview, and a lot of those features pertain to ways Labview programmers like ourselves can hook into the Labview editor. And one of the things that I learned pretty early on is that it made sense to have a Labview-specific place where plugins could be loaded from, and a Labview version-independent place where things could be loaded from. And so that's a pattern that you're going to see in a lot of these sort of G-based hook type features of the Labview editor. You can put your plugins in a spot in the Labview folder, or you can put your plugins in a spot that's outside of the Labview folder. And when you put your plugins in the Labview folder, those plugins obviously only pertain to that version of Labview. When you put your plugins in the version independent location, which is almost always in the Labview data folder, then those plugins can work across any Labview on your system as long as the version of Labview you saved your plugin in is that current version or older. So just to demonstrate, let me bring my Windows Explorer window back over here. So Labview 2020 resource plugins pop-up menus. These pop-up menus right here, all of these pop-up plugins, all of these LLVs, you can see these are in my Labview 2020 folder. So anything in this folder only applies to my Labview 2020 editor on my computer, specifically my 32-bit Labview 2020. Now, if we go into Labview data, we will also see a pop-up menus folder. And inside of there, check it out, there's my spell check. So in this Labview data location, this spell check plugin is now available to any Labview version on my system. However, I did my demo in Labview 2020 and I saved my plugin in Labview 2020. So even though I've got a bunch of other Labviews installed on my computer, this spell check's only going to work in any Labview version that's 2020 or later. So this won't appear in any of the menus for these older Labview versions because I saved this plugin in Labview 2020. Now, if I had done my demo in 2015 and saved it here, now this plugin would be available in any version from 2015 and onward. So those are the things you need to consider. We had some chat conversation during Stefan's presentation about like how to distribute these types of features. Like if you want to distribute quick drop plugins, if you want to distribute right-click plugins, if you want to distribute VI analyzer tests, all these other things, how would you distribute them? Well, if you're using something like VIPM, VIPM does version-based installation anyway. So if I were using VIPM to distribute some of my favorite right-click plugins, quick drop plugins, VI analyzer tests, I would have VIPM install it into the Labview folder because that's where it's installing things anyway. And it's very easy in VIPM to switch between Labview versions and install packages to different Labview versions. The only time I would suggest doing things in the Labview data folder is if you are distributing your code manually. Like if you have a zip file and you tell people, you know, unzip these plugins to these locations, you probably want to drop them into the Labview data folder because you don't know what Labview version people might be using. So that's my suggestion there in terms of how to distribute plugins. And that suggestion is kind of a general suggestion for all of these plugin-based features of Labview that have version-specific and version-independent ways to install. All right, so a few caveats. This is a feature that requires scripting. If you've ever heard me talk about Labview scripting, there's a million caveats you have to be concerned about. So this feature is no different. When you write your affected items VI, put some thought into what types of front panel and block diagram objects can this thing work on. Remember, for my spell check, I said, I want this to operate on strings. Now, if I were doing this as an actual official feature instead of just a presentation demo, I would probably have it also work on string constants. So then I would have put that in the affected items array as well. What I would not have done was said, well, it can work on string and it can work on string constant. So let me just make the plugin operate on the shared parent of those two classes in VI Server, which would be GObject. That's a terrible idea. You don't want to set up your plugin to work on GObject because now every time you right click on anything in the entire Labview editor, Labview is going to run the builder VI for your spell check, which it probably won't need most of the time. And that's going to take up some of those precious milliseconds that take place when you right click and Labview runs through all the builder VIs. So instead of saying, hey, I want to work on strings and string constants, let me have my plugin work on GObject, just go into the affected items array, the type def, and have an array of strings and an array of string constants. Now your plugin will only appear on those two things and nothing else. Along those same lines, I can't stress enough how important it is when you right-click plugins to make sure the builder VI is as performant as possible. I was working with a Labview programmer recently. He had me install some packages onto my system that were dependencies for some of the stuff that he was working on. And he had written a right-click plugin that was really useful for his particular project, very specific to his project. But every time I right-clicked a wire, I saw a loading dialog come up because his builder VI was so huge that his builder VI took seconds to load into memory before it could even display the right-click menu. That's a bad builder VI. You want to make sure your builder VI is as lightweight as possible. You want to push all of the work over to the execute VI, which is actually going to be doing scripting. My last caveat, which is a pretty big caveat, so pay attention, is the data type property. The data type property can be very dangerous to read in a right-click plugin. And the reason for this is kind of complex, so I'll try and distill it down a little bit. Labview classes, most of us work with Labview classes, I'm going to guess. Labview classes have a big problem when you try to load them across multiple application instances in Labview. For example, if your project has an RT target in it, and there's a class in the RT target and a class under my computer. I'm sure you've seen this. Both of those classes will be locked. You can't edit the class because it's open in multiple application instances. So all of these right-click plugins, they run in an application instance that is a private application instance specifically for running right-click plugins. Now, if you right-click on something in your My Computer application instance, for example, and it's got a class, and then you, in your Builder VI, let's say you right-click on a class control on a front panel, right? In your Builder VI, you get a reference to that class, and the first thing you do is read its data type. You have now loaded that class in multiple application instances, and having the class data specifically as a variant, which you have with the data type property, having that data open or sort of available to manipulate in both application instances makes you vulnerable to crashing Labview. That's just the way it is. It's probably the way it's always going to be. So if at all possible, avoid reading the data type property in a Builder VI. If you're able to, maybe get a reference to the VI from its original application instance and operate on things there. If you absolutely have to read the data type property, which you'll see if you start browsing through the right-click plugins that ship with Labview, you'll see some of them do. Call the request deallocation function. Again, don't ask me why. That's more of a Stephen question. He says that dropping request deallocation anywhere you read the data type property is going to highly reduce or eliminate your chance of running into those cross-context issues with classes. So again, complicated topic. I don't want to get into any more details, but that's just one of those caveats of writing right-click plugins. Try to avoid the data type property, but if you can't, call request deallocation. All right. So one of the ways that right-click plugins are so performant, one of the ways that we make them so fast, unless you make them really heavyweight, like I talked about before, is that the Builder VI stays in memory after the first time it runs. So sometimes what that can mean is it might be difficult to share data between your Builder VI and other parts of your plugin framework. Global VIs are about the easiest way we have to persist data between runs of your plugin or to pass data between your Builder VI and your Execute VI. Because of the whole stays in memory thing and because of the way the whole framework works, you can't use debugging tools in the Builder VI, so you can't set breakpoints so that you can probe things in the Builder VI runs. So you got to use some of those tricks we've all had to use in those difficult to debug situations. Log some data to a text file or call one-button dialogues. If you've ever used debugwrite.vim, that is a hidden gem, and it is very useful for debugging. It pops up sort of a debug window that sort of shows you data that has been passed through debugwrite, and it's really useful for these types of situations. You can use debugging tools in the Execute VI, which is the one that does the scripting. So if you need to set a breakpoint in there and probe your scripting code and check for errors, that shouldn't be a problem. It's just the Builder VI that it's hard to debug. And then finally, if you have a menu item that launches a separate dialog, like the rearrange cases one that I showed earlier, it's good practice to have ... on the end of the menu item text. That tells people that if they pick that menu item, a separate dialog or process is going to start. All right, so there is a bug in the right-click plugin framework. After all this great stuff I told you about it, now I'm telling you that there's a bug in it. Remember, the feature was added in Labview 2015. We found a bug that we fixed in Labview 2020. And this is a bug that we kind of knew about the whole time, but we never could narrow it down. And we finally figured it out. NI might be releasing a patch to 2019 that includes this bug fix. I don't know if that's going to happen or not. But it's a very simple thing to fix. There's a manual fix you can download from the right-click plugin community. But this race condition, it's pretty rare, but it does happen. And the symptom is you right-click on something and select a menu item and nothing happens. Or even more confusing, you right-click on something, select a menu item, you see your diagram change for whatever thing you right-clicked, and then the change goes away and it acts like you never did the thing. So anyway, if you ever see that happen, it's because you have not manually applied the fix to your Labview 2015 through 2019. So if you Google the terms that I have on the slide there, it'll be the first link that comes up, or if you download these slides from ni.com/lvmenus, you can click the link. But I suggest every Labview programmer apply this bug fix if you're in 2015 through 2019, just so that you don't get the occasional 1 in 100 right click, something doesn't happen. I don't know why. Do it again and it works. It'd be nice to not have to deal with that and wonder why. So everybody apply that bug fix if you can. All right, that is all the content I have. We've got a few minutes left for questions. I can rearrange my windows now and see if I can find the Teams window so I can see people's chat. Ah, came up. All right, so does anybody want to catch me up on any questions that anybody has for me that I missed in the chat window?
I think if you just look at the last 2 messages, these are the things that came up that haven't been like answered in some way, shape, or form.
Yes, so Christian is asking, is that the reason the change to array sometimes reverts? It absolutely is, yes. And somebody noticed, Darren says that it happened with removing rewire a few times. Yes, it's irritating because it happens so occasionally, you're like, you lose faith in the editor, which is like the worst thing, right? So get that fix applied that I talked about on the previous slide. Or if you're in Labview 2020, it's already there. Or if you're in Labview 2019, we might be releasing a patch that includes that fix, among other things. So yes, very annoying bug. Glad we found it and got it fixed in. 4 years too late, but better late than never.
Okay, so while your presentation was going on, we had 2 more polls. One was, who has installed different Labview versions on the same machine? And interestingly, 47% say, yeah, sure, no concerns, and only 53% say, nah, only 1 version per VM, maybe.
So I have a bunch of Labviews installed on my machine because I work at NI, right? And I worked in Labview R&D. If I'm working on projects that involve drivers, there is 1 VM that has 1 Labview on it with 1 set of drivers. Because having multiple Labviews and trying to manage drivers across those is ridiculous. But for the purposes of working for Labview R&D, and I've got to reproduce bugs and see if one happens in this Labview versus another. If drivers are not involved, I'm happy to have lots of Labviews on the system. Once drivers are involved, 1 VM with 1 Labview and driver set per project. That's what I do. That's my procedure.
And the other poll was about who uses Labview 2020 already, like in real life or in production, and it's 55% to say yes,
cool,
doing 2020 already. Stefan typed another question into the chat. Do you prefer to use quick drop or right-click plugins to do the same thing?
Yeah, so that's a great question. Here, if I go into my slides and go back over to bit.ly/cnat-lvhooks. I go into in this presentation, which I can give to you guys at your next user group if you want. I talk about why I use quick drop versus right click versus pull down versus VI analyzer tests. And ultimately what it comes down to is, if it is an operation that I perform multiple times, like dozens to hundreds of times per day, I'm probably going to use a quick drop plugin because the keyboard is the fastest way to interact with the Labview IDE, right? If it is a very context-sensitive operation, I'm going to probably make it be a right-click plugin. For example, if it's something that I can only do on wires, it makes more sense to me that it's a right-click on a wire and not a control space when a wire is selected. Now, there's a few exceptions to that. For example, there are some things that I do hundreds of times a day on a sort of a boundary that is smaller than a selection. The best example for that is create constant. I do create constant hundreds of times a day. I almost wish I could do that with a quick drop keyboard shortcut because the keyboard's so fast. But terminals are sub-selection items. So I can select a match pattern function with my mouse. I cannot select any of the 7 terminals on match pattern with my mouse. My mouse can get to that terminal level, and that's why create constant makes more sense to me to be a right-click menu operation instead of a quick drop operation. Now, if somehow I could select a terminal with my mouse and then do something with the keyboard, it might make more sense for me to do something with the keyboard to create a constant, but we're not there yet. There's a few ways to sort of, in a hacky way, do that, but they don't work that great. So, with few exceptions, quick drop plugins are very consistent, repetitive editor actions, dozens or hundreds of times a day. Right-click plugins are context sensitive. I only do this on a certain type of thing, so just show it in that thing's menu type of operation. Hopefully that answers the question.
I think it does. Makes sense what you said, of course. Yeah, well, I guess looking at the chat window seems to be it. No more questions at this point. Oh, is it by preference you have omitted the project provider plugins?
Great question. So as you can see in the list there, project providers are not listed. I actually do talk about project providers in that presentation at bit.ly/tnet/lvhooks. There is a section of that presentation called Rusty Nails, where I talk about features that you should never, ever use, and project providers are one of those features. So yes, I do talk about them, but maybe not in the way you'd expect or hope.
Good to know. I was just about to look into those.
Don't look into them.
Save some time, I guess. Awesome. Darren, thank you so much. I mean, it's always a pleasure to listen to your presentations. And we're only halfway through this whole meeting and my head's going to explode anytime now, I think. So I will take some time to go back and watch those things again, the recordings. I will happily take you up on your offer to have you back on WUELUG again for one of the other presentations. There's so much to learn. In a fun way, actually. So thanks for taking time out of your day again. And we'll be happy
I really enjoyed it.
Thank you. Thank you so much. So listen, guys, I think we should have a small break. Probably 5 minutes should be enough to cycle through